Hi everyone, welcome back to math class. Yay! So today we are going to be working with arc length, and this is different than arc measure, which we previously worked on, because we are no longer working with the degrees, because measurement was in degrees, and the length will be obviously length, it's a distance. So the arc length formula is L equals x times c over 360. Now, let's talk about these components. Now, my initial understanding was L is for lambda, but I think I'm wrong. It is that cursive L, so you do have to write it like that. If you can find out what this L means, let me know. I'll give you some extra credit. And then X stands for the degree measure of the arc. And then C, of course, stands for the circumference of the circle we are talking about. So let's put this into use to build our understanding of arc length. So for number one, I see a circle with a degree measure inside of 107, and I notice that the radius is 6 meters. So I'm going to set up my equation. Arc length equals 107, which represents x, which is the degree measure of the arc I'm concerned with, times 2 pi 6, right? Because remember, circumference is 2 pi r. So since my radius is 6, I just plug in 6 for r, all over 360, which you can gather is the entire degree measure. And when I simplify the numerator, I get 1,284 pi over 360. And when you put that in your calculator, it will calculate into approximately 11.21 meters. And again, please make sure you are writing your unit, as it is important for length. And that's it. That's all that is required for arc length. So I'm going to skip number 2 and let's move down to number 3. So in the bold, and I'll make it pink so that we can see it more clearly as well, we want the arc length of the arc that I've highlighted in pink, right? Now, there's 2 ways to go about this. You can say, well, I can just go ahead and find the difference and find this arc length and do my calculation. Or you can find the arc length of 142 and then subtract and do etc., whatever you need to do. I'm going to do the first method. So 360 degrees minus 142 degrees equals 218 degrees. So this entire degree measure is 218 degrees. Now I can go ahead and start finding my arc length. So this would be 218 degrees times 2 pi, the radius is 4, all over 360 degrees. Once you simplify and once you solve, your arc length is going to be approximately 15.22 centimeters. And that would be your final answer. Okay, nothing overly complicated here. So I'm going to skip 4 and then we will do 5 here. So 5 reads, if EB equals 15 centimeters, find the length of CD. So I'm going to label these with colors. If EB is 15 centimeters, find the length of CD. CD is right here. Okay. So now, obviously, before I find the length of CD, I am going to need to know the degree measure of this angle. On the inside, it's opposite angle on the inside. And the way I can do that is, again, I looked at, this is the diameter, so on a line, right? In order to find this measure, all I have to do is 180 minus 68 degrees. And I get 112 degrees. So the measure of the opposite of the pink is 112 degrees. Let's do that also in pink. Okay, and it looks like I have all the components I need. So arc length equals 112 degrees, times 2 pi, the radius is 15, all over, sorry, I had a little brain fart, 360. Okay, simplify that and clean that up, and we get arc length is approximately, ooh, that 2 looks weird. It's approximately 29.32 centimeters. Okay, and that's it. That's all we need. 6 is very similar to that concept as well. And then as we move on to the next few problems on the next page, I will just do 8 and 10, as well as 12. Okay, so for number 8, it reads that JH is 21 inches. So J to H is 21 inches. Find the length of arc KJG. So remember, if it has 3 points, this is a major arc. So I'm starting at K, roundabout to J, all the way back up to G. So this arc is basically the entire circle. Okay. That means I have to find this entire degree measure on the inside, and I can do that with just a few steps. Sorry, here we go. So let's look at getting that done. So this is 59, that's accounted for. We have 85 here. That means I have to find this component, and I can do that very easily. Again, I check that this is the diameter, right? It's going right across my circle through the midpoint. And then I have 85 as a linear pair next to the unknown. So I'm going to do 180 minus 85, which is, I believe, 95. It's always those small problems that you think like, oh, maybe I get it, maybe I don't. All right, so this is 95 degrees. All right, well, if this is 95, the other thing that I know and I'm familiar with is that 95 actually has a vertical angle because of these two intersecting lines. L is also 95 degrees. Okay, that being said, I'm going to go ahead and make sure that I have everything I need for this portion of the circle. 59, 95, 85, 95. All right, let's add them up. So we've got 59 plus 95 plus 85 plus 95, and that entirety is 334 degrees on the inside. Okay, that means now I can go ahead and start my equation. So arc length equals 334 times 2 pi r. Oh, and actually, I can use 2 pi r, but the smarter one to use, because circumference is 2 pi r and also pi times diameter, it's actually better for me to use this formula. So I'm going to write pi times 21, because the diameter was 21, all over 360 degrees. So math, algebra, clean that up, and your answer is going to be approximately 61.21 inches. Okay, that's it. And then let's look at number 10. So here it tells us if WS is 4.5 millimeters, find the length of TS. Now, if you feel more comfortable labeling your things before you get started, that's fine. So the radius here is 4.5, or you can say the diameter is 9 millimeters. That's cool. We need to find the arc measure of TS, and that is right here. Okay, which means I need to know the internal measure from here to here. All right, well, that's not too bad. This one requires you to know, what's it called? Vertical, oh my gosh, I'm really blanking. Vertical angles. So notice here that 128 is opposite this entire part here, right? So W plus something is going to be 128. Actually, you know what? No, I'm sorry. Let's do it another way. I'm going to go ahead and do it with that 180 way. Again, 128 has a linear pair. We don't know what it is. So this is going to be 180 minus 128, which is 52. So this part here is 52. 52's vertical angle is also 52 right here. Okay, now we're getting more information. Now think about where would we, what else would we find in order to find the missing internal angle? There's a few things. You could say, let's use a highlighter. You could say, well, this is a line, and I would be able to find the missing component here, right? Or you could say, well, if this is 128, its vertical angle is W plus something, right? Then, oops, you also have this component that makes 180. So, I'm sorry, I'm not doing a good job explaining this. Let's just look at it like this here. We have 180 minus 52, which is, of course, 128. So together, all of this is 128. In order to get away that missing slice, think about what needs to happen. Oh, and then actually, I just noticed we have 31 right here. So this is actually also 31 degrees. So we're going to do 128 minus 31, which is 97 degrees. Now we can go ahead and solve this. So length of the arc is 97 times, I'm going to go ahead and use the diameter one, 9 pi over 360. Clean that up and we get 7.62 millimeters. All right, sorry that explanation was a little bit messy. If you stuck with it, great. If not, come see me. I will try to re-explain it in a better way. I just didn't want to re-record the video and start all over again. And the last one we're going to do here is number 12. A car entered a roundabout from Mason Avenue, traveled 280 feet, then turned onto Perry Street. If the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car traveled. Excuse me. So I'm going to go ahead and draw myself a little circle. If you don't know what a roundabout is, it's where cars, there's like street openings, and you kind of have to travel around and exit off on those. There's a few in Summerlin. If you've been there, I'm sure you have. Anyway, so a car entered a roundabout from Mason Avenue. Let's say Mason Ave is right over here. And traveled 280 feet, then turned into Perry Street. If the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car traveled. So I'm going to go ahead and also put the diameter here as 150 feet. And it doesn't matter what 280 feet looks like, so I'll just do this much. 280 feet, and it got off on Perry Street, right? So if the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car traveled. So they actually gave us the arc length this time. So L, or the length, is 280 feet, equals, what we don't know is the degree measure inside. So X times, we do know the diameter, so pi times 150 over 360. All you need to do here is cross multiply. Just remember 280 is over 1. and we're going to get 280 times 360 equals x times 150 pi. So 280 times 360 is 100,800 equals x times 100. Oh, sorry, pi 150. I'm going to divide both sides by pi 150. And x equals approximately 213.9 feet. However, it did say round to the nearest degree, which means the whole number on the ones place. So x is equal to 214 degrees when we round. Okay, and that's it. So the next few pages are review, and then you will take your, well, just the next page is review, and then you'll take your quiz. And after that, you'll keep moving on. All right, guys, I'll see you next time. Bye.